It is with great pleasure that we welcome all our viewers back here at Crystal Clear Electronics videos. Now, I'd like to give the word to Mr. Szabolcs Pájer to continue our review of the basics of mathematics.
Üdvözlök mindenkit! Mostani részben a logikai, vagy más néven Boolean algebrával fogunk megismerkedni.
Boolean algebra is the mathematics of statements that are clearly classified as true or false.
Vagy egy hamis kategóriába sorolhatók.
In the following cases, the false statements will be marked with a digit 0, true statements will be marked with a digit 1, so the value of the logical variables is either 0 or 1. This way, everything that can be written as answers for a series of decidable questions, yes or no, can be encoded using Boolean algebra. This code can be immediately written with digits as well, which is the same as the binary numeral system. Take the number 13 base 10 as an example, then convert it to binary format. The first decidable question could be the following. Is there any group which contains exactly one element? Based on the figure above, we have a single unit, so the answer is true, coded as 1. The second question, is there any group which contains exactly 2 elements? You can see that there isn't any, so the answer is false, a 0. We could continue in the same way with questions for groups 4 and 8. We can define logical variables which have a truth value, true or false. With these logical variables, mathematical operations can be done. The simplest of such operations is the denial, or in other words, negation, in English not, which assigns false to true and true to false. An A logical variable's negation is called A negated in speech, or simply we call it not A or A not. Its sign is capital A. The easiest way to illustrate logical operations is to use the truth tables, which shows the value returned by the operation in addition to the possible values of its variables. The first operation to be described that works with 2 logical variables is the OR operation. The appropriate technical term is disjunction. The sign of the operation is plus. The A plus B statement is true only if either variable A or variable B values are true. In the OR operations truth table, the operation's result will be 0 only if both variables are 0. The OR operations truth table is as follows. The next bivariable operation is the AND. The technical term is conjunction. Its sign is dot. A.B statement is true only if both variables are true. Although any kind of logical statement can be constructed using just these operations, in practice, primarily in digital electronics applications, additional operations are introduced. The 3 most common ones are the not AND, the not OR, and the exclusive OR. The not AND and the not OR operations are the negated form of the AND and the OR functions respectively. Take a look at the truth tables. The exclusive OR operation is different from the OR operation in a way that it is only true if exclusively only one variable is true. We can write down this logical connection with the help of our previously introduced functions. This function is true only if A is true and B is not true, or if A is not true and B is true, i.e. A.B plus A.B. This logical connection is marked with a plus symbol in a circle. Let's look at the truth table. In case of the exclusive OR, it was easily soluble how to write down the statement with the help of our basic operations. Let's try 2 similar tasks. Write down the not AND and the not OR functions equivalents with the use of AND, OR, and negation operations. If we do these, we get the De Morgan's laws we learned in high school. Let's look at these in the truth tables. Here is a physical implementation of the NAND gate seen in the last truth table in this IC with 8 legs, shown here.
What you have now placed on the table is representing an 8-pin IC. That's how our table connects with the crystal clear electronics curriculum, that it actually represents a NAND gate.
That's right. What has been said about Boolean algebra is sufficient to learn the rest, although we could go on at a more detailed length. See you in the next video. Bye!
Sziasztok!
Bye!